Today we're going to have an introduction to prisms. A prism. A prism is a polyhedron. A polyhedron that consists of a polygonal region and its translated image on a parallel plane with quadrilateral faces connecting corresponding edges. Now that's a lot of stuff, okay, that you don't really need to write down, okay? A polyhedron, a many-sided three-dimensional figure. A many-sided three-dimensional figure. Or solid. Although some polyhedrons can be hollow, when we talk about prisms in geometry, we're just going to assume that they are solid. A prism is named by the shape of its base. So we start off with a rectangular base, and we have another rectangular base. There's our three-dimensional shape. Now I'm going to correct this a little bit because this edge here should be in the background, right? You shouldn't be able to see that. So the solid lines represent what you can see, and the dashed lines represent what's in the figure but on the back side. So they're just there so you can see that they exist. So we're going to say that this base here and this base here are parallel to each other. That's what we mean by a polygonal region and its translated image on a parallel plane. Polygonal region for base 1 and a polygonal region for base 2. And they are parallel to each other. And they are connected with quadrilateral faces. So if we look at this face here in the front, that's a quadrilateral. And this particular prism, because it has a base that is a quadrilateral, it has 4 faces, or 4 lateral faces. If the angle between the base and the lateral faces is a right angle, then it is called a right prism. If it is not, then it is called an oblique prism. Okay? We also name the prism according to the shape of its base, like I said before. So in this case, if this angle here is 90 degrees, I know it's drawn kind of crooked, but let's assume that angle is 90 degrees. In other words, this angle between the base and the lateral face. If it is 90 degrees, then we're going to call this a right rectangular prism. Okay, it's a right prism because its angle here between the base and the lateral face is 90 degrees, and its base shape is a rectangle. So we could have triangular prisms, rectangular prisms, pentagonal prisms, hexagonal prisms. In other words, the base of the prism can be any shape at all. Now let's talk about a diagonal. When we talk about a diagonal, we're going to talk about the diagonal of a right rectangular prism. So here we have a right rectangular prism. The diagonal is a segment whose endpoints connect to two different faces of the prism. So if I start from this corner at the left front and I go to the corner at the right rear, remember this is inside the prism. That is the diagonal. Now if we look at this, diagonal, we see that between the length of the diagonal and this side here, which I'm now going to color in blue, I have two sides of a triangle, don't I? And if I connect those now, if I connect this back corner with the front corner, remembering that this is a right angle here as well, I've made a right triangle. So I can use a modification of the Pythagorean theorem to find the length of a diagonal. And I'm going to say that the length of the diagonal is equal to the square root of the length of the prism squared plus the width of the prism squared plus the height of the prism squared. So here's length, width, and height. So if I know those three values, I can find the length of any diagonal. I'm going to move this up a little here. So here's an example. If I have a prism, a right rectangular prism, that has lengths or edge lengths of 5 for the length, 3 for the width, and 7. Oh, let's make that 8 for the height. What is the length of its diagonal? The diagonal is going to be the square root of the sum of all these squares. 5 squared plus 3 squared plus 8 squared. So the length of the diagonal equals the square root of 25 plus 9 plus 64. So the diagonal equals the square root of 98. Whatever that number happens to be. What is that number? Approximately 9.8 units, right? Approximately 9.8 units.